Hello, this is Math 2270 coming to you from the College of DuPage for summer of 2020, and this is a lecture entitled Solving Non-Homogeneous Systems of First Order Linear Differential Equations. Okay, by way of introduction, we've talked about this in concept before, and so if we're solving a non-homogeneous matrix equation, this is what makes it non-homogeneous, is that capital F of t is not equal to 0. It's going to be composed of two things. It is going to be composed of a complementary solution, a solution of the homogeneous part of the equation, and a particular solution. And the complementary solution, or the solution of the homogeneous equation, is a linear combination of these basis vectors, or we call it a fundamental set. And x sub p is a particular solution of the non-homogeneous. And we knew how to obtain this in the previous section using eigenvector techniques and eigenvalue techniques, and now we're going to discuss two ways of finding xp. Now, one method is called undetermined coefficients, and that's what we talked about with annihilators and generally the guess and check method, and variation of parameters. Now, it turns out, now as then, of the two methods, variation of parameters is the more powerful technique. However, there are instances when the method of undetermined coefficients provides a quick means of finding a particular solution. So we are going to deal with that first, and then we'll talk about variation of parameters. Alright, so here is an example. You're to find the general solution to the following system, and this is the vector x prime is equal to, this is a times x, that's the homogeneous part, plus, and this is the non-homogeneous part, this is t, and the vector is 2 minus 4. Now, it turns out we solved this homogeneous part earlier, and what we learned when we did this was that associated with the eigenvalue minus 1, this was the eigenvector, and associated with the eigenvalue 4, this was the eigenvector. So that means my complementary solution is a linear combination of those two. But now we're looking at this, and we're going to guess, since this is 2t and minus 4t, we're going to guess that this particular solution has the form t times a vector a plus a vector b, and since we don't know what these are, that's why they call it undetermined coefficients. These are the coefficients that we're going to determine. So there's a vector a, and there's a vector b. Now, if we take the derivative of this, the derivative of a constant is 0, so and the derivative of t is just 1, and so we get that the vector xp prime is just equal to a. And we're going to simplify notation a little bit to go forward, and we're going to say that this is of the form a times the vector x plus t times a different vector g. Okay, so let's substitute this assumed solution into our differential equation and figure out what we have. So when we do that, we knew that the first derivative is just a, and then I'm substituting t, a vector, plus b vector into the equation. And so when I do that, I will use the linearity properties and the distributive properties here, and I'll move this vector a to the other side, and I get this is my vector equation. So the 0 vector is equal to this. Now, the only way that can happen is for both of these coefficients to be 0. So when I say the first coefficient is equal to 0, this is what I get. And that means that matrix A times vector A is the negative of vector G. And so we go down and we write that down, and this is what we get, and that tells us that when we solve this system of two equations and two unknowns, that vector A has to be 3 and minus 5 halves. Now similarly, our second equation, this one, when that is equal to 0, that means A times the vector B is equal to the vector A. So we take that value, we substitute down here, and we find out that b is equal to minus 11 over 4, and that is 23 over 8. So that tells me that my particular solution is this one. And when I add it to my general solution, I get this as the general solution to the non-homogeneous differential equation. I would like for you to do one, so here's what you're to give a go at. Find a general solution of this non-homogeneous differential equation. And here I tell you what A is. It is a 3 by 3. And here I tell you what the vector G is. You know what to do. Let's see how you did. Well, we have to solve the non-homogeneous perhaps first. So what we're going to do is we're going to look at the determinant of A minus, and we're using R here instead of lambda, but that is lambda I or Ri. So we subtract the R off the diagonal elements, and we compute this determinant, and this is what we get when we simplify. So you see we have a root of multiplicity 2 at 3, and at minus 3 we have a root of multiplicity 1. And so those are the roots. We have two roots at 3 and 1 at minus 3. So we need to find the eigen vectors. So when r is equal to 3, we will substitute 3 into this equation, and we will get this. Now that tells us that minus u1 minus u2 plus u3 is equal to 0, and that will tell us that our solutions are going to look like this: s minus v, v, and s. And whenever I'm thinking about these, I could let v be 0, or I could let s be 0, and I get this. So my eigen vectors associated with 3 are 1, 0, 1, and minus 1, 1, and 0. And so those are the eigen vectors that I get for that one. And for r equal minus 3, what's going to happen is I'm going to end up with this equation to solve, and I'm going to get that minus s, and 1, and so that's minus 1, and 1. So now those are three independent, linearly independent vectors. So the general solution then is going to be the linear combination of the three. And so this is my solution to the homogeneous part of our equation to solve. So this is part of our solution. Now we have to turn our attention to t times g, and again we're going to be able to assume that x sub p is equal to t, and then this is going to be a1, a2, a3, b1, b2, b3. Again, what we're going to do is we're going to substitute it into the equation. We'll end up with two equations and two unknowns, and we will solve this, and we will learn that a is 5, 2, 4, and b is 1, 0, 2, and that means that this x sub p is, I can combine those, and I will have 5t plus 1, 2t, and 4t plus 2. So the general solution is going to be the solution of my homogeneous equation on an earlier slide plus this one. Now, the method of undetermined coefficients is not as straightforward as it would seem. There's a whole bunch of special rules and so on and so forth. And rather than delving into these difficulties, we turn instead to the method of variation of parameters. And we do that in 38.1.